So today we're going to learn the third way that you can write the equation for a parabola. It is what is referred to as the locus definition of a parabola. This has always been on the Regents exam, so we definitely got to make sure we go through this. So first, in order to do locus definition, you need to understand what a locus is. So a locus is the collection of all points equidistant from a given point. So if they give you a point, all the points around it that are equidistant from that one spot, that is your locus. So the locus is basically the collection of that. So with parabolas, what happens when we find the locus is really we're given a fixed point, which we refer to as the focus, and then we're given a fixed line, which is known as your directrix. And you're trying to find all the points that are equidistant from that point and that line, and it creates the shape of a parabola. So once we get that parabola, we have to write its equation. Now here's the same equation, just written in two different ways. It does not matter which one of the two that you use. However, you do need to memorize it. That will not be given to you. So if we're looking at the equation, no matter which one of these you're looking at, this H and this K, just like what we were talking about last class, that still makes up your vertex. HK is still your vertex. So that's the same as I said from last time. As you'll notice, in both equations, they're in a slightly different spot, but still, those two values are still your vertex. So then we do have a new value in here, which is the letter P. So P represents the distance from the vertex to the focus, which remember is that point. And then the vertex to the directrix. So your vertex is going to end up being directly in the middle of those two things. So it's going to be directly in the middle of your point, which is our focus, and your line, which is your directrix. So P represents that distance in between those things. So down here I have a picture for you guys, so you can see it. Right up here is our focus. This line is our directrix. So those are the fixed values. The point, focus is fixed, the line is fixed. Here, as you can see, my little squiggly, from your focus to your vertex, that distance is represented by P. Your vertex to your directrix, that is also P, so it's always equidistant right there. And then what ends up happening is any point on your parabola, so I had picked this point right here, any point on that parabola, though, is always going to be the same distance from your focus to that point, and then your directrix and that point. Those are always going to be the same. So let's take a look at some examples down here where we're going to kind of keep working on that whole notion of points being equidistant from the focus and the directrix. So I've given you the graph here of the equation 1/4 x squared plus 1. The focus is right there at the point 0, 2, and I labeled it for you with an arrow. And then your directrix for this example is the x-axis. So right there on your x-axis, that is your directrix. So then again, the parabola just represents all of the points that are going to be equidistant from that focus and that directrix. So our first question here is they want to know how far the turning point, which is 0, 1, right there, how far is that from both the focus and the directrix? So this one's one that we can easily count. How many units between the vertex and our focus? 1. And then how many units between the vertex and the directrix? 1. So 1 unit from both of them. So in the second question, it wants to know from the point 2, 2, what is the distance from the focus to that point, and then what is the distance from the directrix to that point? So if I start with my focus, how far away is it from that point? 2. And then how far away from it, from the directrix, is that point? 2. And that's what's always going to happen. Any point on that parabola is always going to be the same distance from that focus and from that directrix. So now those ones were a little easier. You can easily count for those ones. Let's pick a point that's a little more difficult. So let's take a look at the point 4, 5. And we're going to show that it is the same distance from the focus and the directrix. So the easier one to do is that directrix. How far away is that point from the line? 5, because we could just count 1, 2, 3, 4, 5. So that's 5 units away there. And then if I try to figure out the distance from our focus to that point 4, 5, can I easily count? No. However, we can make ourselves a beautiful right triangle here. And then what could we use to figure out the distance? The Pythagorean theorem, a squared plus b squared equals c squared. So let's count. This side is 1, 2, 3, 4. And then this side is 1, 2, 3. Anybody remember that triple? 3, 4, 5. So that means this distance is 5. So they're both 5 units away. So on the back here, consider a parabola whose focus is the point 0, 7 and whose directrix is the line y equals 3. Sketch a diagram of the parabola below and identify its turning point. So it's always easiest, I think, when you have a little picture. So I'm going to first draw in my axes there. So I got my xy axes. Not very straight, but they're still there. So I'm going to draw on the two things that they told me. They told me my focus was the point 0, 7. So I'm going to estimate that to be up here. And then our directrix is that line y equals 3. So I'm going to draw that in. And so our vertex always lines up directly underneath wherever your focus is. So that means the x value is always the same. So since the x value from my focus is 0, the x from my vertex will also be 0. But I just have to figure out what value for the y is in between a 3 and a 7. Right here at 5. Now, if you can't see that, all you have to do is take the average. 3 plus 7 divided by 2 gives me 10 divided by 2, so the focus or the vertex is going to be at 5. You can always take the average of those two y values to get you where your vertex is going to be. So what's going to end up happening is the parabola would then be drawn going up that way. So then B, determine the equation of the parabola using the locus definition. So the one that I have seen used most often would be this one. Y equals 1 over 4p times x minus h squared plus k. Because what does that look like? It's very similar to vertex form. So that's why that tends to be the one that they use a little bit more often than the other formula on the front page. So that's the one that I like to practice using. Looking at my problem over here, I already figured out my h and k because I have my vertex. Yeah. Not Friday, but your test, yes. So hk, those are my values I'm going to use in my equation. Our value of p, again, how far is that vertex from our focus and our directrix? It's 2 from the directrix, It's 2 from the focus, so our p-value is a 2. So then we can plug it into the equation. So y equals 1 over 4 times p, so 4 times 2 gives me an 8. And then x minus h squared, so x minus 0 squared, plus my k, which is a 5. So I'm just cleaning that up a little bit. We don't need to write x minus 0. We can just leave that as x squared, so 1/8 x squared plus 5. Let's try another one. Number 3, determine the equation of the parabola whose focus is the point 4, 1, and whose directrix is the horizontal line y equals -3. So again, I'm going to sketch myself a picture. The focus is the point 4, 1. So that would be approximately over there. Got to go to the right 4, up 1. And my directrix is the line y equals -3. So in order to write our equation, we need to know two things. We need to know our vertex, and we need to know the value of p. Okay. So is anybody willing to venture a guess where the vertex is going to be? No, not 2. 4, -1. It's going to be right there in the middle. 1 plus -3 divided by 2. If we take our average, gives us our -1. The x is always going to be the same as the x from your focus. So 4, -1. And then our p-value, how far is that vertex from both the focus and the directrix? 2. So our p is also a 2 again. So again, there's our formula, there's our equation we're going to use. 4 times 2 gives us a 1/8 there, because we figured out p was a 2. Then it's x minus 4 squared minus 1. So number 4, they want us to find the vertex, axis of symmetry, equation of the directrix, and the focus. So I'm going to make myself kind of a little list over here. Got to find the vertex, axis of symmetry, directrix, and the focus. And they gave us the equation over here. Now the equation that they used is the other one. So it's x minus h squared equals 4p times y minus k. That's the format it is written in. You could rearrange it to be like the other one that we've been doing, in which case if you did, you would divide by 4. That would give you 1/4. X minus 3 squared equals y plus 2. And then subtract your 2. So then you can get it into the other one that we've been using on the other two. So whichever one you use, whether it's this first one or rearranging it, what is our vertex? 3, -2. So in our axis of symmetry, who remembers what is the axis of symmetry? The x value from your vertex. So x equals 3. All right, Directrix and Focus. So first we have to figure out is what is our value of P. So whether you are using this first one or this one, it still ends up being 4P equals a 4. So then if I divide by 4, what is our P value? 1. So that means the focus is going to be 1 higher than your vertex. So that would be at 3, -1. Since my vertex was at 3, -2, we'll go up 1. And the directrix is going to be 1 lower. So y equals -3. So our last thing for today are applications of quadratic functions, so our word problems dealing with quadratic functions. We always have two kinds of word problems. We have a word problem where it's looking for something to hit the ground or for something to land in a stream or, I don't know, hit the water of some kind. It always hits the ground or something of some kind. So in that case, you're looking for the root, so you have to set the equation equal to 0. So if you're looking for ground, when it hits the ground, you're looking for the root, so you set your equation equal to 0 and you solve. So you can do the square root method, factoring, quadratic formula, completing the square, any of those 4 methods we've gone over. If it wants you to find anything dealing with max or minimum, so the maximum height or the greatest profit or the most revenue, or if they're talking about the least amount of cost, something along those lines. You're looking for the maximum or the minimum of the parabola. So you have to start with the axis of symmetry formula, -b over 2a. Do you guys remember seeing -b over 2a? Yeah. Remember, it's the first part of your quadratic equation also, your quadratic formula. -b plus minus square root. Right there. That first part, there's your axis of symmetry formula, so if you don't remember it, it's always there for you. So you've got to find that first. That always answers the time question. When does it reach its maximum height? When does it reach its maximum profit? How long does it take to get the maximum whatever? That is your -b over 2a. And then you simply plug that value back into the equation, and it gives you what the maximum height is or what the minimum value is. So this first part, the -b over 2a, answers the when. And this basically answers the what is the height or what is the minimum value. So let's take a look at our 2 examples, or we have more than 2 examples. First example, an object is fired upwards with an initial velocity of 112 feet per second. Its height in feet above the ground as a function of time in seconds since it was fired is given by the equation here. Find the time that the rocket reaches its greatest height. So again, we're looking for the time when it reaches its greatest height. So we're looking for something dealing with the vertex, and it's the time part of the vertex. So we got to do -b over 2a. Time and vertex, -b over 2a. So what's our b value from the equation? We get -112, because we're supposed to put in there -b. Our a value, -16. So I can go ahead and calculate that. -112 divided by -32. What do we get? 3.5 seconds. So it's going to take 3.5 seconds for this object to reach its maximum height. Didn't ask for the maximum height, just when it got there. So 3.5 seconds is when it gets there. Second part, algebraically determine the time when the rocket reaches the ground. So we're looking for when it gets back on the ground, so that means we need to set it equal to 0. So our negative 16t squared plus 112t, we got to set that equal to 0 so we can solve. This one is factorable. It has a GCF. I'm going to take out a negative 16t, because remember back with factoring, if that first term is negative, take out a negative. And that gives me t minus 7 in my parentheses. So we get 0 and 7. Now, why is 0 not our answer? Yeah, 0 seconds. That represents when it started. That's time of 0. That's the beginning of the problem. So it takes 7 seconds. Now, as you notice, that just took the first time and doubled it, but does not always work that way. So don't just try to double your value from your maximum there. All right, number 2, we got the height of a ball above the ground at time t seconds is given by that equation. When does the ball attain its greatest height? And then they want to know what is that height. So we got to start with negative b over 2a. When does it get to that maximum? So what do we plug in for b? Yeah, negative 140 over 2 times negative 2. And what do we get? 35. So that's going to take 35 seconds for it to get to its maximum height. So then again, answer part B, we're going to plug 35 into the equation. And let's see what we get. Anybody get a number yet? Should be kind of a ridiculously high number. 4,050. So did they give us a unit for the height, like feet, meters, centimeters? No. Then we don't label it. So in our third one, we got a cliff diver in Acapulco, jumps from a cliff 17 meters above the water. His height in meters from the water, t seconds after he jumps, is given by the formula there. How long will it take for the diver to reach his maximum height? I know, it's a typo. So we're just looking for when they get to the maximum height. So negative b over 2a. So our b value from the equation is negative 1.5. A is negative 4.9. You should get a decimal. 153 seconds. Which makes sense because when you jump off a cliff, you don't really jump up that high. So. So in our last one, the path of a golf ball for a new player is given by the equation there, where x represents the distance in yards from the player, and f of x represents the height in feet of the ball. Find the total number of yards that the ball travels. Okay, so what do you think we should do? Yeah, we got to find maximum because x is the distance in yards. that the ball ends up traveling. F of x represents the height of the feet of the ball. So if we wanted to know how high it went, we would plug a value in for f of x. But we're looking for negative d over 2a this time. Which, are we going to be able to easily get that from our equation? No. What form is our equation written in? Vertex form. Do I even need to calculate anything? No. Where is the x value of our vertex? What is it? 23.7. So that is it. All travel is 23.7 yards.